start with this example first. Let us take a system of linear equations in two variables, a1x, b1y plus c10, a2x plus b2y plus c2 equal to 0. This is system of linear equations in two variables x and y. If you have done method of cross multiplication, you must have seen the way x, y can be determined. Otherwise, there is method of elimination, method of substitution. But if you do it with the help of method of cross multiplication, what you do there? We write a1, b1, c1, a2, b2, c2, then again a1, b1, a2, b2. To solve this system of equations, we put x over there, y over there, and 1 over there, not equal to. And then we see that x by b1 c2 equal to y by, see, if you put downward arrow, this is positive, upward arrow is negative. Then y by c1 a2 minus a1 c2, and then 1 by a1 b2 minus a2 b1. Okay, and xy we write this manner, x equal to b1 c2 minus b2 c1, a1 b2 minus a2 b1, y equal to by a1 b2 minus a2 b1. This solution is possible if a1 b2 provided a1 b2 minus a2 b1 not equal to 0. But have you ever thought that this method is not going to work if we have system of three linear equations, a1x, b1y, c1z plus d10, a2x, b2y, c2z, d20, a3x, b3y plus d3 equal to 0, because not so easily we can find the values of x, y, z. But we can think it bit different manner. For simplicity of our calculation, right now these three equations I am putting this form, equal to d1, equal to d2, equal to d3. Same thing, just taking d1, d2, d3 on the right side. Now if we go back to this solution part, if we write bit different manner, this thing, x by b1 c1 b2 c2, y by c1 a1 c2 a2, and then 1 by a1 b1 a2 b2. Is there any difference? No. Here what I am doing, coefficients I am writing first here b1, b2, c1, c2, but I have used bracket this manner. This is something is called a determinant. This is going to be a determinant. This determinant we can find its value by remembering this quantity in our mind, b1 c1 b2 c2, it has value b1 into c2 minus b2 into c1. This determinant d2, this we are referring as d1, this one as d2 and this one d. d2 is what? c1 a1 c2 a2. This we have written as c1 a2 minus c2 a1, and this d is what? a1 b1 a2 b2. Okay. Now right hand side, nothing was there, that c1 c2 was there. With little bit modification of the same thing, this determinant is a 2 by 2 order determinant, 2 by 2 order determinant, 2 by 2 order determinant. If we modify this thing here, this solution going to be x by, I will be writing d1, d2, d3, then these coefficients b1 c1, b2 c2, b3 c3, then y by, this column will be replacing by d1, d2, d3, a1, a2, a3, d1, d2, d3, c1, c2, c3, and then z by, this will be replaced by d1, d2, d3. Rest will remain the same. a1, a2, a3, b1, b2, b3, and this is d1, d2, d3, and finally it is 1 by this coefficient determinant, that is a1, b1, c1, a2, b2, c2. These are also determinants. I have just extended and manipulated some terms here. I get these determinants. These are known as dx, dy, dz and d. Then the value of x will be dx by d, y will be dy by d, z will be dz by d. This is a determinant, but we don't know the value. Here finding value was very easy. When we are finding it, d's value was a1 b2 minus a2 b1, that we have written. We have cross multiplied this way. That's why it is called method of cross multiplication, isn't it? So here what to do? That will definitely derive a rule for that, that is expansion of determinant. But this time I wanted to tell you the idea of determinant. Where does it originate? Where does it come from? It has origin in solving equations, and this rule is known as Cramer's rule of solving. Cramer's rule of solving system of linear equations under the condition this d not equal to 0. This d not equal to 0, then only solution. No, in other case also it exists. Right now I am referring d not equal to 0. This is the case of getting a value of x, y, z. Okay, this is a version of method of cross multiplication. Okay, so this is determinant of order 3, order 3, order 3, order 3. Now we will be checking all these things with different manner. Suppose we have a square matrix. A square matrix is of this form of 2 by 2, A1, B1, A2, B2. This square matrix, this is square matrix A. We will be denoting its determinant by date A. You write this thing, or date A, which is equal to A1, B1, A2, B2, and its value is A1, B2 minus A2, B1. Okay. For example, if I take one very simple example, say we have to find determinant of this matrix 2, 3, 7, 1. This determinant value A is this. Then date A going to be determinant of 2, 3, 7, 1. This one you can do nicely, that is 2 into 1 minus 3 into 7. 2 minus 21, that is minus 19 is the value of a 2 by 2 determinant. Okay, but to find the value of 3 by 3 order determinant, we need to know minors and cofactors. That I will explain step by step. When solution of equation was done, all these values were calculated initially and then they are put into the form of determinant. I am going to show you how to get the value of a 3 by 3 determinant. Let us take a determinant of third order in this form, that A1, B1, C1, A2, B2, C2, A3, B3 and C3. This determinant we are going to evaluate. This value of this determinant is given by A1, expanding in terms of first row, minus B1, this we are writing expanding in terms of elements of first row, B1 into A2 C2, A3 C3, C1 into A2 B2, A3 B3. Now you might have two questions here. Number one, where did I get the rule? Number two, can't we expand in terms of second row, third row, or first column, second column and third column? In the second question, my answer is yes. You can expand in terms of any row this manner. Let me complete this part. That A1 into B2 C3 minus B3 C2, B1 A2 C3 minus C1 into A2 B3 minus A3 B2. Okay? Because expansion of these determinants of order 2 we have studied. Just downward arrow positive and upward arrow negative. We have done this way. So value of determinant is this only. Matrix has no value. If it was a matrix of the form A equal to A1, B1, C1, A2, B2, C2, A3, B3, C3, it has no value. No value of A. So what we are doing? We are doing value of determinant of the matrix, that is det A, written in this symbol, and you get the value. For example, I take one example for you. Say I am taking 2, 3, 4, 3 minus 1, 2, 4, 2, 6. What's the value of this? It will be 2 into minus 1, 2, 2, 6, minus 3 into 3, 2, 4, 6, plus 4 into 3 minus 1, 4, 2. So this value is going to be 2 into minus 3 into 18 minus 12
minus 10.
Yeah, 18 minus 8, 18 minus 8 plus 4 into 6 plus 4. Okay, so this will be 2 into minus 10, 3 into 10, 4 into 10. Value will be minus 20, minus 30 plus 40. 40 minus 50, answer is minus 10. Okay. A question arises automatically what we actually did there. When we have taken 2 here, I have not taken this row and this column. I have taken this part only. Minus 1, 2, 2, 6. Alternate plus minus, then minus sign here. Then what we did? We did not take the same row where 3 there and column. Apart from this, 3, 2, 4, 6. Then about 4. For 4, what we are doing? We did not consider any element of this row and this column. So, plus 4 into 3 minus 1, 4, 2. This way we have expanded. Now question arises, can we do it in terms of second row? Can we do it in terms of first column? Yes, definitely we can do, but before that, we learn 2 terms here. That is, one of them is called minor and the other one known as cofactor. So we are going to learn minors and cofactors. What are those? If we write minor of an element in a determinant Mij, that is minor of ijth element, which is obtained by taking remaining elements of the determinant except the ith row and jth column. We'll think that ith row and jth column is not there. Remaining determinant is the value of Mij. I am writing one thing here. Just taking a determinant of this form. A11, A12, A13, A21, A22, 23, A31, A32, A33. If we want to write M21, okay, we want to write the value of M21. So what we'll do? It is situated in the second row and first column. We'll delete, we'll imagine that those elements are not there. Remaining part is what? A12, A13, A32, A33. Its value you can find easily. A12, A33 minus A13, A32. This is M21. Okay. You can write minor of any row, any column. If you want to write minor of this particular element, that M31, no, this is 32, sorry, M32. How to get that? You don't take any element from third row and second column. Remaining value of the, remaining part of the determinant will be a 2 by 2 order determinant, already reduced. And this is A21, A23. Value is A11, A23, A13, A21. Clear? These are minors. This way you can find the minor of any element. Now we learn how to calculate the cofactor of an element of determinant. We found the minor of a particular element. Now we are going to define cofactors of elements. Just this is by definition Cij, cofactor of ijth element will be minus 1 to the power I plus j. This is our I and this is j into Mij. Okay. Cij going to be minus 1 to the power I plus j Mij. Cofactor of ijth element. Suppose in this problem, we want to find C21. It will be minus 1 to the power 2 plus 1 M21. So it will come with a sign, either positive or negative, minus this thing. A12, A33, A13 and then A32 minus. Okay. So now let us do one numerical problem here, taking the determinant this manner. 2, 4, 10, 3 minus 1, 6, 4, 2, 8. We want to write, say, C31. This will be what? Minus 1 to the power 3 plus 1 M31. Apart from this row and this column, whatever there, that we have to take for minor. And this is becoming minus 1 to the power 4 is plus M31 is 10. This is 24 plus 10, of course. You are right, it will be 34. Understood? Now, let us see some calculation what we have already done. That if this is our determinant. If this is the determinant, the way I have expanded in terms of first row, it will be A11 into A22, A23, A32, A33 minus A12 into A21, A23, A31, A33 plus this thing A13, A21, A22, A31, A32. Okay. So now this A11 is the element and this thing is what? We can say minor M11. This is what? Minor M12. This is what? Minor A1, M13. But if we write it in this manner, minus 1 to the power 1 plus 1 into minor plus minus 1 to the power 1 plus 2 into this minor plus minus 1 to the power 1 plus 3 into this minor. Wait a minute, I forgot to multiply this. This is A12 is there, no? We must write A1. So what have I got now? If this one corrected this manner, we write A12 minus 1 to the power 1 plus 2. A13 minus 1 to the power 1 plus 3. Then we can write this as A11 C11 because this thing is C11 by formula. Minus 1 to the power 1 plus 1 M11. This we can write A12 into C12, and because this thing is C12, minus 1 to the power 1 plus 2 M12, and this thing is A13 C13 because C13 minus 1 to the power 1 plus 3 is positive only AM13. Hope you have understood. We can express the value of determinant in terms of rows of an element into corresponding cofactors and then taking the sum. If you say that, can you write the value of determinant in terms of second row? Yes, we can. Just for that determinant only, delta equal to, just writing here very first, A11, A12, A13, A21, 22, 23, A33. Then this thing going to be equal to, if I expand in terms of second row, we'll get the same value A21 into C21 plus A22 into C22 plus A23 into C23. Somebody says that, can't I express in terms of columns? Of course, it will be A11, C11, A21, C21, A31, C31. Doesn't matter. You take a particular row, elements, multiply those elements by corresponding cofactor and then find the sum, you will get the value of determinant. I will show you one example where it will give us the same value if we expand in terms of a row or in terms of a column. We are taking 214, 317, 426. We find its value by using this thing. 2 into 2 means this I am expanding in terms of first row. It will be 2 into what? The cofactor. Cofactor is what? 6 minus 14 minus 8. Because minus 1 to the power this thing will be positive. Then plus 1 into cofactor of this thing minus 1 to the power, this is 1 to element. Okay. So there will be a minus sign. Then remaining part, that is 3746, 18 minus 28 plus 4 into this thing, 3 1 and 4 2. So this will be 6 minus 4. Value is minus 16, no, minus 16 here. Minus 16, and this is 10 plus 10 and 8. So the value is 2. When you have expanded in terms of the first row, we get this thing. Let us expand in terms of second column. Expanding in terms of the second column, that is 1 into this element is 1 to element C12, again this one into C, this is 2 2, and then plus 2 into this element is what? This is 3 2 element into C32. This I am doing carefully because expanding in terms of first two we have done before. Here when you are doing, I will write all the cofactors, not mentally, but writing exactly what's the cofactor. C12 is what? Minus 1 to the power 1 plus 2. C12 will be what? This element, this row and this column will go, it will be 3 7 4 6 minus 1 to the power 2 plus 2. For this element, this one, this column will go, remaining is 2 4 4 6, and here it is plus 2 into minus 1 to the power 3 plus 2, 3 2 element, third row and second column, third row and second column, it will be 2 4 3 7. Value is, and this is plus 2 into minus 1. So this is 10 minus 4, and this is minus 4. See, the value is 2 only. So it is irrespective of the fact that you are expanding in terms of a row or in terms of column, both the ways it will give us the same value. We can expand in terms of any row or any column we want to. So let us evaluate one of the determinant of order 3 in this form. Just evaluate, find the value of number 1 0 sin alpha minus cos alpha minus sin alpha 0 sin beta cos alpha minus sin beta 0. So let us expand by using the concept we have just got. We can expand in terms of any row, any column. So by expanding in terms of first row. Expanding
স্যার স্যার ইনসেটে তিনটা করে যাচ্ছে আর এটা কোথা থেকে
0 plus this is from A given, then so that determinant of 3A equal to 27 into det A. To answer this, you first get the value of determinant A. 1 into 4 minus 0, 0 into something is 0, plus 1 into 0 minus 0, value is 4. So RHS is what? 108. Left hand side you first multiply. Det 3. How to get det 3? You multiply this by 3, this matrix by 3. When you multiply a matrix by an element, then all the elements multiplied by all the entries of matrix multiplied by the same scalar or same element. So this is 3, 0, 3, 0, 3, 6, 0, 0, 12, minus 0 into 0 minus 0, 3 into 0 minus 0. So this is 108 only. So left hand side is equal to right hand side. In the next problem, they asked you to verify. I am telling you, this is very important property of a determinant. If we multiply two matrices and then take the determinant, it is actually product of the value of individual determinants. That only they have asked you to prove. In the next session we will learn this one as an important property of determinant. So how to answer this thing? You first multiply A into B by using matrix multiplication. 2, 5, 2, 1 into 4 minus 3, 2, 5. So row by column matrix multiplication you all know. This is 8 plus 10, 18, minus 6 plus 25, 19, 8 plus 2, 10, and minus 6 plus 5, minus 1. The value going to be minus 18 minus 190, that is minus 208. RHS, this is LHS we got, sorry, determinant sign I forgot to put. Must be there, you are finding determinant finally, no? So this is actually we found this value 18, 19, 10 minus 1. RHS is what? It is determinant A into determinant B. This is nothing but 2, 5, 2, 1. This multiplied by 4 minus 3, 2, 5. So 2 minus 10 is minus 8, and this is 10 plus 6, no, 20 plus 6, 4 into 5, 20, minus minus plus 26. So 160 and 48, this is also minus 208. Please remember this as important result. This is true for any two determinants of same order. Determinant of their product is product of their individual value of determinants. Now let us go for this one. If d equal to this, then d is what? The age of, this time is of MCQ questions mainly. So you must know how to answer this. So before you answer, I have taken this just after expansion, means here property will not be very good for you, properties of determinant. So better you expand. 1 plus sine square theta, then minus sine theta into 0 plus 1 into sine square theta plus 1. This is going to be 2 plus 2 sine square theta. This is 2 sine square theta is 1 minus cos 2 theta. So it is 3 minus cos 2 theta. Now less than equal to 1. So this implies minus cos 2 theta greater than equal to minus 1, less than equal to 1. Therefore, you add 3 on both sides. Therefore, okay, so this option is correct. Clear? This is just an expansion. Properties of determinant definitely will apply, but not for these simple problems, even for this one. What's the value of this determinant? What is the correct answer? The delta going to be 1 plus c square minus a into and if I expand, it is 1 plus c square plus a square minus abc even if you have done properties of determinant already. But remember, some problems like this, if it is a 1 mark MCQ, properties, use a property worthless. This is time consuming. So we'll simply find it just by expansion. Clear? No problem. We can express the area of triangle formula by using determinant. Sometimes it helps a lot. If we take 3 vertices as x1, y1, as we did in class 11, area of triangle ABC half mod of x3 multiplied by y1 minus y2. This we have to write with the help of determinant. Can we write this manner? x1, x2, y2, 1. Of course we can write. Because this, if you expand, it will give you we just expand this determinant. Value is x1. I am expanding in terms of column, first column, minus x2 y1 minus y3 plus x3 into y1 minus y2. Okay. So how you get this thing, this into this form? Because if we rewrite it, this is going to be x1 plus x2 plus x3 y1 minus y2. So this is appropriate. Okay. Because, or just a minute, here it is plus, no minus sign, by mistake it was there. Now it's okay. So this whole thing is actually value of the determinant. So area of triangle now going to be delta ABC equal to half of x1 y1 1, x2 y2 1, x3 y3 1. But what is the advantage of this thing? Sometimes if you know, now if 3 points are collinear, no triangle can be formed. So 3 points ABC are collinear if area of ABC is 0. This implies half okay. This is the condition for collinearity of 3 points. Now let us find area, one sum, then collinearity like that. Find the area of triangle. Just if we take this example, whose vertices are 2, 7, 1, 1, 10, 8. So area of ABC will be what? Half into 2, 7, 1, 1, 1, 1, 10, 8, 1. Clear? This will be half into 1 minus 8 minus 7 into, I am expanding in terms of first row, plus 1 into, so this will be half into minus 7. Half will be multiplied to all the terms. So half into minus 7, and this is minus 9 and minus 2. So 63 minus 9, 27 square unit. So that following points are collinear. So that A, B plus C, C plus A, C A plus B lie on the same line. Remembering in the form of determinant, area of triangle is, I'll say that, easier than the way you used to memorize in class 11. So if you want to prove the collinearity, we'll start with this thing, A, B plus C1. We can prove it nicely with the help of properties, but here this is enough. A into C plus A minus B minus B plus C, B minus C, 1 into, just expanding in terms of first row, 1 into AB plus B square minus C square minus AC. This will get cancelled. Plus AB minus AC. So minus AC plus AC get cancelled, AB minus AB get cancelled, value is equal to 0. So this implies that A, B, C are collinear. This is a common problem. We'll do it by using properties also. It comes nicely. Here we have just expanded. Now take another one like this thing. Question is, if the area of triangle is 35 square unit, area of a triangle, area of a triangle with vertices 2 minus 6, 5, 4 and K4 is 35 square units. The question is, find the value of K or go by option. Then K equal to what? 12 minus 2, both minus 12 minus 2 and 12 minus 2. Let's see which one correct. First we put area, that is that I told you to take modular sign over there. So when you are answering this, it will be half 2 minus 6 1, 5 4 1, K 4 1 whole modulus. This is for determinant and this is for modulus, is equal to 35. You can remove this mod sign by taking plus minus on the right side. 2 minus 6 1 and then 5 4
So minus
1.
2 at 12.
K41 equal to plus minus 35. Why? Because I have removed the mod sign. This thing is removed. So if mod A equal to 2, if then A equal to plus minus 2. It is something like that. So now by expanding, let us find the value of K. I have to take both plus and minus. Some I am doing because of that reason, otherwise you will be wrong. Now expand in terms of first column. This will be 2 into 0 minus 5 into plus K into wait a minute, minus 5 into minus 6 minus 4 plus K into minus 6 minus 4. My God, same thing. This implies this is 50 minus 10K plus minus 70. So taking plus sign, this is equal to 17. Therefore, K equal to minus 2. Clear? Taking minus sign, $50 minus 10K equal to minus 70. So 10K 120, K equal to 12. So two values of K both are acceptable, minus 2 and 12. Part D, option D is the answer. Clear? Why have I done this sum? Because most of you will do mistake here. When you are removing mod, you forget to put plus minus there. Okay? Hope understood.